So it's given that the x normal distribution of mu and sigma square and the probability of x less than 3 is equals to probability of x more than 7. Alright, we need to write down the value of mu. Okay, so from here, right, if you're thinking, given that looking at the question, we have the probability of x less than 3 equals to the probability of x less than 7. Right, what does this tell us? The value of mu. Right, so this is one thing that it may be a question on your mind. So from here, how do I find the value of mu? So here, what I can suggest is you draw out the normal distribution. You know that the graph, we are looking at normal distribution. So if we want to talk about the x less than 3 equals to x, you must also think about, try drawing out and think in terms of area. Think in terms of area, right? Means the area is equal, right? So how would probability of x less than 3 look like? Let's see if you're not sure. You can see if you think about it, mu is the center. Right, so if we just make an educated guess, x less than 3 could be somewhere here, right? And what about more than 7? So probability of x less than 3 and probability of x more than 7 is somewhere here, right? So what does it say? If the problem is equal, then remember that the normal distribution curve is bell shape. It is symmetrical about the mean, right? So what does this say about the center, right? So you can see that mu here must be the midpoint of 5 and 7, of 3 and 7, sorry, 3 and 7, right? So basically mu is just equals to 3 plus 7 divided by 2 should give you 5. Okay? Right, so here a lot of times if you're unable to solve, it is good to actually draw out the normal distribution graph. Alright, so my next question is, does it mean that the probability of x less than 2 is equals to probability of x more than 8? Right, what do you think? Right, the answer is yes. Okay, so does it mean that the probability of x less than 4 is equals to the probability of x more than 6? What do you think? Yes, okay, because it's symmetrical about the mu, which is equals to 5 in this case. Alright, and next, very quickly, right, given that the probability of x less than 2 is equals to x more than 8, so we need to find the sigma square. Okay, next will be the what we did just now, which is to find given that the probability, the 2 times of probability of x less than 2 is equals to the probability of x less than 8, right? How do we find sigma square? So very quickly, what we can see is first of all, just now remember I was telling you that if you observe the graph, right, it's symmetrical, right? So because the center mu equals to 5 and mu is equals to, and no, left hand side is 3 and 7, we can think about with 2 and 8, then we can also say that the probability of x less than 2 is equals to the probability of x more than 8, right? So here, over here, we can also rewrite, think about using this symmetry to rewrite x less than 8 as 1 minus probability of x more than 8. And this is also can be written as probability of x less than 2, alright, because we are using this equality here and we're going to sub it here, alright. And with that, okay, this is just a 2 times of probability of x less than 2, and which means that we have the probability of x less than 2 to be equals to 3 to 1. The probability of x less than 2 equals to 1/3. I'm sure from here, will you be able to know 5? I'm sure from here, now mu is equals to 5 and sigma is unknown. So how do you find? How do you find sigma square? How to find sigma square? Right? So remember, you look at the notes, right? Remember, there's always certain questions that emphasize on having, mu and sigma to be unknown. So how do we approach questions like this? All right. So think about it. Go to lecture notes. Basically, we need to do the standardization. All right. We standardize the variable. Right. So we need to change it into the standard normal variable, which is to have z to a normal distribution of 0, 1. So how do we do that? From here, basically, we change it to z less than 2. Right, so remember we have to minus mu is 5, and we divide by sigma. Alright, this is equals to 1/3. And if you inverse norm this, right, so what we do is we take this, we inverse norm 1/3 0 1, because a standard normal distribution will be mu 0 and the standard deviation will be 1. Alright, we'll just get our 2 minus 5 over sigma to be equals to negative 0.43727. Alright, and just solve this on your own. I'm sure you can get your sigma square, right, to be approximately 48.5. Okay, we are